Alright folks, I think the video got cut off for the time zones, but I think you guys get a sense of the different time zones. Don't forget there's a great section in your textbook packet, the one that I made photocopies for everybody on page 18. It gives you a little more breakdown of our different time zones. I also want to remind you, kind of referenced it through the video lecture, that we divide the world in half and we locate different hemispheres. So visually, again, we kind of divide, if we're using the equator as a dividing line on the left of your screen, you can see we have something known as the northern hemisphere, and then we have the southern hemisphere. And if you're using the center portion, which is the prime meridian, we reference the western hemisphere, which we're located in, which is North America, and then we also have the eastern hemisphere. Now, part of identifying location, we're going to be talking in class and reading your textbook of something called absolute location. Absolute location, we use a grid-like system using lines which are known as latitude and longitude to identify a precise location on the globe. Now, for the most part, we don't really say when we talk about location, absolute location. For example, if we're going to go to Starbucks, we're not going to give someone exactly a grid, well, this degree's latitude and this degree longitude. We usually talk in the sense of relative location, what it's next to. It's right around the corner from Anaheim High School, for example. But just going back again, latitude, we're talking about lines. And the trick I remember for latitude, I think of lat is flat. So they run all the way from 0 degrees, which starts at the equator, all the way going up to our poles, which will be 90 degrees. So visual right here of our latitude lines. And at the same token, we also have our longitude lines. So longitude lines are run in the direction of the North Pole to the South Pole. And these are the lines that we also included or were referenced when we talk about how we divide up into time zones. They go 0 to 180 and they circle the globe. And remember, long lines equal longitude, or whatever little trick might help you remember the difference. One thing I do want you to keep in mind when we are talking about absolute location, or even your textbook, it will also reference it as mathematical location. The way we read coordinates, latitude can only be measured in north and south, and latitude always goes first. So for example, if you're getting the coordinates of 60 degrees south, you already automatically know they're referencing lines of latitude, versus longitude, which we're measuring east and west. And longitude will go second no matter what, in the case, for example, 135 degrees west. Finally, another way that geographers address location, I want to introduce what is known as projections. Now, projections are talked about in key issue number 1 on page 8. There's also a section that we're going to be looking at more in depth when we get into our unit on maps. But just to kind of reference, if we're talking about trying to take a round object like the Earth and trying to flatten it out so we can utilize it when we start looking at different maps, it's obviously very difficult. If you think, for example, if you took an orange and you try to peel it off the skin, if you took an orange and actually try to draw, this might be a fun activity in your free time, draw a map on the orange, and then you try to peel off the skin of the orange and kind of lay it flat down, you're going to see that it's going to come out kind of funky. And that kind of funkiness we refer to as distortion. So when we look at projection maps, we say that there's going to be distortion in their shape, their distance, their relative size, and their direction. One of the most common projections that you're probably very familiar with for location is a projection known as the Mercator Projection. So this type of map is probably, again, what has been hanging in your previous elementary school classrooms or even in some textbooks. And then one thing I want to call your attention to is the distortion. So for example, on this particular map, one would think that Greenland, which is located up here, is bigger or just as large as Africa, which is down here, which is totally not the case. So landmass is seriously distorted in this type of projection. A lot of people say this is seriously outdated, and it also gives way to, in terms of not necessarily identifying the power that Africa has to offer. A lot of people refer to this as a political map because Africa is not given necessarily the credit it deserves of being one of the largest continents on our globe. You maybe recognize this one as well. This is the interruptive projection. And then we also have one that is the Robinson projection. Now the Robinson projection is moving in the right direction. You can see right here Africa is represented larger in the center. But this projection is difficult for geographers because it really distorts, or kind of it makes it very difficult to read the landmasses at the poles. So that most geographers say it's a better job, it's moving in the right direction, but there's still some sort of distortion that it makes it difficult to read and identify location. The last projection I want to introduce you folks to is something known as the Peters projection. Now this one might look a little strange, it's not something we recognize, but it definitely acknowledges the sheer mass of Africa continent, kind of highlighted. And there's definitely been a push for a lot of atlases and textbooks to adopt this projection. So let's pause right here and we're going to watch a little video clip that kind of pokes fun at Peters projection.
John Fowler, Dr. Cynthia Sales, and Professor Donald Hugh.
Hugh?
Hugh.
Okay, and you are the Organization of Cartographers for Social Equality.
Well, we're from the OCSE. We have many members.
How many?
4,300 dues-paying members.
What are the dues?
$20 a year for the newsletter.
Let's start.
Wait, I want to see this.
This is Josh Lyman.
You are.
Josh, this is Dr. Fallow, and
Hi.
Ms. Mary Men.
Yes.
Should we begin?
Yes. Plain and simple, we'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Give me $200 and it's done.
Really?
No. Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas at the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But
Yes.
it distorts the relative size of nations and continents.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Yes?
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
No way. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
It has fidelity of axis.
Fidelity of position.
East-west lines are parallel and intersect north-south axes at right angles.
What the hell is that?
It's where you've been living this whole time. Should we continue?
Uh-huh.
All right, folks, as we wrap up for today's lecture, I just want to kind of review in terms of some things that we covered. We did cover quite a few items, kind of some introductory, basic review type of information. So we started off with a little bit about geography. We watched a short video about what we can do with geography. We begin to make sure that we identify the difference between human and physical geography. We went back to basics covering continents and oceans. We introduced some information about different time zones, understanding that the globe is divided into different hemispheres, understanding that to identify absolute location we use a grid-like system known as latitude and longitude lines, and then finally we introduced the way we also identify location using different map projections with the Robinson, Peters, and Mercator projection. Alright, so using this list in front of you right now, again a good reminder, I would also pause after any flipped lecture and just make sure you go back through your notes. If there's something that you missed, the convenience is you can go back through the YouTube video and replay that section. I would also make sure that on the left-hand column or post-it notes or some sort of strategy I would go through and identify main topics. even ask yourself a series of questions. This can be a great way that you can use your notes for a study tool. And then finally, I would always finish up a flipped lecture with writing a brief summary to see if you can identify the main important aspects of each of these topics. All right, I look forward to seeing you guys back in room 106. #APHUG Life.